All right, welcome, guys. So, this particular question reads like this: a company's executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has a salary in the top three unique salaries for that department, right? So we need to write an SQL query to find the employees who are high earners in each of the departments, right? So basically, what they are asking us to do over here is that we need to find the employees whose salary falls in the top three salaries for that particular department to which they belong, right? And we need to do it for every department. Correct. So this again is your employee table over here, which has the employee ID, the employee name, the salary of the employee, and the department ID of the employee. And this is the department table, which have the names of each of the department corresponding to the department IDs. Right. So this is what is given to us. Now this question is an extension of the previous one, right? Which we just solved, wherein we were supposed to find out the highest salary from each of the department. The difference here is that now we need to find the top three salaries instead of just one from every department. And we have to retain the ties as well, just like we did before, right? So now the approach to this problem will be to simply use partition by on department ID and find rank for each of the salary using dense rank. And dense rank, why we would be using dense rank? Because again, we don't want holes in our ranking sequence in case there are ties at any point, right? And then we will just filter out the records with rank less than or equal to 3, and this will give us the top 3 salaries for each of the department, right? So that is pretty simple. And again, a point to remember over here is that we will be joining this particular table and this particular table to get the department names, not initially, but after finding the top 3 salaries. And this will lead to lesser number of rows when we are actually joining these two tables, right? Because now, I mean, this particular table will only have records with rank less than or equal to 3, right? Nothing else than that. So, I mean, the rows will definitely be lesser compared to the original table. And then when we are joining over here, our queries will be more performant, right? So we are doing optimization over here, correct? So now maybe let's just write this query. Let me head over to my SQL server. Okay, so I think let me just remove this. I had done this before. Yeah. So now if you see, let me just select the results set of these two tables. So now if you see, as we saw in the sample data, we have the employee ID in the employee table, the name of the employee, the corresponding salary, and the corresponding department ID. And in the departments table, we have the department ID and the name of the department, right? So now, as we were discussing in the approach, let's start by writing the partition by, writing the rank for each of the salary, partitioning by the department, right? So for that, let me just write a select statement on employee like this, and then let me select the columns that I'm interested in over here: the employee name, the department ID, salary, and then I'm going to use the dense rank function to basically calculate the rank of every salary over partition by department ID, order by salary, descending. Why descending? Because again, I'm interested in finding the highest salaries. I'm interested in putting the highest salary at the top and find the highest top three salaries. I'll just alias this as RN. And now I'm going to use this entire query as a subquery under this outer query. Why? Because I want to filter based on this calculated column called RN, and this will be accessible from the outer query. Correct? So yeah, let me just put this like this. Let me alias it as A, and I'm going to say where Rn is less than or equal to 3, right? And let me for now select star from this entire query so that I get an idea if I'm getting the right output or not. Okay, there is a, I've missed the order by, right? Oh wait, I was seeing this salary. I should have seen this salary. That's fine. Now let me just run this. And as you see, I get the result. I get the name of every employee, the department ID, the salary, and the rank. And this result set is corresponding to only those employees whose salary fall in the top three salaries for every department, right? So if you see, we are getting the top three employees based on the salary, not the top three employees, but the top employees based on the salary which fall in the top three salaries of that particular department, right? So this is that. Now what we need to do is, as a final step, we need to bring in the department name. So we need to replace the department ID in the result set with the department name, right? So for that, we just need to join with the departments table. And for that, again, we can use a CTE. Going to use a select statement over here. A inner join with the departments table that we have as B on A dot department ID equal to B dot ID, right? And over here, I can just select these three. So now we can just take name from the B table as well and alias it as department, and can just employ the alias over here, and I can run this. There is a syntax error. Did I do something wrong? Yes, there is a typo over here. Is this? Run this now. Now we get the result. We get the department. For every department, we get the employees who are the top earners, basically whose salary falls in the top three salaries for that department. We get their names. We are also getting the department ID, which I will remove, right? Because we don't need that. We have already gotten the name. Again, I'm doing it at the wrong place. So let me remove it from here. Yeah. And we are getting the salary, the corresponding salary of each of the employee, right? So this is the query for this particular problem.